Hey guys, so today what we're going to do is we're going to talk about the difference between alkanes, alkenes, and alkynes. Now, I reviewed a little bit of this already, kind of when we just briefly introduced hydrocarbons. So at the top here it says draw a six-member hydrocarbon with a triple bond between the second and third carbon. So can you draw a hydrocarbon with six carbons, put a triple bond on it, and have that triple bond be between the second and the third column? Carbon. If you could, it would look something like this. Pause the video and try it. Okay, it looks something like this. Notice here how here's my second carbon, here's my third carbon. It's got a triple bond between it. And then since there's four bonds coming off of the second and the third carbon, there's no hydrogens on those two. Every other carbon needs to have four bonds coming off of it. So where there's not, four bonds, it's going to create extra bonds and put hydrogens around it. So this is an example of an alkyne. Alkyne, Y-N-E, is anything with a triple bond. Now, you could have drawn it like this, and that would be perfect. But remember, these objects can kind of turn and rotate in three dimensions because they're three-dimensional objects. So if we rotate it, realistically, depending on which way you're looking at it, whether you're looking at it like this or, you've turned around and you're looking at it like this, either way, um, you could also say that the second carbon would be this guy right over here. So something that we do in organic chemistry is when we're talking about which carbon is first and which carbon is second, that's not as helpful as which carbon is the outermost and which carbon is the innermost. So we would say that these carbons are 1, 2, and 3, going from left to right. And then going from right to left, the carbons on the other side are also carbons 1, 2, and 3. So even though we have six carbons, there's not really a carbon four, because while you could call the fourth carbon here carbon number four, realistically, if you count it the other way, it's carbon three. And then same thing, there's no fifth carbon, because if you count five from left to right, you could also just count two over the other way. And remember, they flip, they're reversible. So, anyways, that's going to come into play when we start talking about naming these compounds. We'll never really use a number greater than five while naming these compounds, and you'd only use five if you have like a 10 carbon chain. So, one of the things we want you to be able to do is identify the difference between an alkane, A-N-E, an alkene, E-N-E, and an alkyne, Y-N-E. Alkanes are all single bonds. Alkenes are all single bonds except it's got one double bond. And an alkyne is all single bonds except one has a triple bond. That means an alkane is saturated, right? Saturated means all bonds are single bonds. And then it's got this formula CnH2n plus 2. Alkenes are an unsaturated hydrocarbon. That means they're a carbon with one double or triple bond. And they've got this formula CnH2n. And then alkynes also saturated, and this is their formula. Now, we're going to go over exactly why the formulas are the way they are in a little bit, but for now, I need you to write these formulas down: the alkane, the alkene, and the alkyne. Okay, so using these formulas, you should be able to identify which one is which. Let's look at the first one. It's got 20 carbons, and then it's got twice the number of hydrogens. That's an example of an alkene, because CnH2n is saying whatever your number of carbons is, you have twice the number of hydrogens. For B, B is an example of an alkyne, because it has twice the number of hydrogens as carbons. Instead of 100, it's got 200, but then minus 2 because it's 198. So that's what this formula is saying. Take the number of carbons, double it, and then subtract 2. And then this last one, as you might guess, would be an alkane, just because it's got 500 carbons and 1,000, hydrogens plus 2 gives it 1,000 plus 2. Okay, so what I wanted to do is just ever so quickly show you kind of how the formulas come to be when we talk about alkanes, alkenes, alkynes. I'm going to use a hydrocarbon with 6 different carbons. So then you'll see how with an alkane, it's got 14. With an alkene, it's going to have 12. And with an alkyne, it's going to have 10. Let's start with the alkane. So here's the deal. This is what it looks like when you have six carbons. Every single carbon is going to have four bonds coming off of it. So if you're a carbon in the middle here, that means you're going to be bonded, two of your bonds are going to be to two other carbons. That's true for every carbon except for the outermost, the carbon over here and the carbon over here. They only have one bond bonded to a carbon, so the other three bonds have to be taken up by a hydrogen. So if we think about it, realistically, what we're saying is the 2n part of that is just that every single carbon has at least two hydrogens coming off of it. Then you have the two on the outside that have two extra bonds, just because they need a total of four bonds, just like every other carbon. They have, and then they're going to need two extra hydrogens. So if you think of the 2n as every carbon, interior or exterior, needing two hydrogens, and then you think of the +2 as the two extra hydrogens that the exterior carbons need, that might help make sense of the formula. With alkenes, once again, we're going to deal with a six-member carbon, kind of just like before. But then with an alkene, we have to add a double bond somewhere. So let's say we add it on between the first and the second carbon. Well, if we do that, then we're going to have to get rid of two hydrogens. Because if we don't, if we just add that bond in without getting rid of those two hydrogens, you're going to have five bonds on your carbons, which cannot happen. So if we form a double bond here, we have to get rid of two hydrogens. The same thing is true if we move the double bond over to the next carbon. Again, we have to get rid of two hydrogens. It doesn't matter whether you take hydrogens for the top or the bottom, but it does matter that you take one hydrogen away from the second carbon and one hydrogen away from the third carbon. Kind of moving along the hydrocarbon here, you'll notice that for every single one of these, always, we're taking away two hydrogens. It doesn't matter whether it's the top one or the bottom one, but what does matter is that two hydrogens are getting rid of. So the formula really isn't CnH2n. It's kind of like you double your number of hydrogens, add two, and then take away two from wherever the double bond is. So it's kind of like a +2 -2 almost. Switching gears here, let's look at alkyne. Once again, we're going to start with just a regular 6-carbon hydrocarbon. Notice that I have my 24 hydrogens. But now when I add a triple bond, now I've got 3 bonds between the two carbons, so they can't have pretty much any hydrogens around them, except for this carbon on the outside has the 1. So in this case, it's kind of like I double my hydrogens, add 2, and then take away 4. And that's true, once again, no matter where the triple bond is. In any one of these cases, there's always 4 bonds on the carbon, but if it's in an interior carbon here, like carbon 2 and carbon 3 here, you'll notice that there's no room for any hydrogens, just because all 4 of our bonds are between the two carbons, or between carbons. So yeah, that's what an alkyne looks like. And of course, this is just an example of an alkene up above. So in general, this is what an alkane looks like. It's got all 14. With an alkene, we have to get rid of 2 of them. And with an alkyne, we have to get rid of 4 of them. And it doesn't matter where the double bond is or where the triple bond is, you always have to get rid of 2 or get rid of 4. Okay. Next part, we're going to talk about naming organic compounds. And the good news is this kind of procedure that we set up for today is what we're going to use for the next couple of days when we're naming other organic compounds. The difference between every organic compound is they all have carbon and they all have hydrogen and they all form long chains, but they have these things called functional groups. And what a functional group is it's just a little thing that's on one carbon that kind of changes its purpose. So for example, a double bond or a triple bond is a type of functional group. By having a double bond, you go from just a regular alkane to an alkene, ENE, or having a triple bond makes it an alkyne. So we're going to talk about how the name indicates a bunch of different things. This is an example of a name, 2-hexene. Notice that there's kind of 3 parts to the name. You have the 2, you have the prefix hex, and you have the suffix in green, YNE. So you have 2 in purple, the prefix hex in blue, and the suffix YNE in green. The first part about this that I want to talk about is the prefix. The prefix will always tell you the number of carbons in the organic molecule chain. This uses, I think it's Greek instead of Latin. It uses Greek prefixes. So, like, oh no, it doesn't, because some of them are a little weird. Anyways, hex means six, as we might know from polygons. So, 6 carbons is the number of carbons you're going to have here. So I'm just going to draw out the 6 carbons. So far, that's what my structure has told me to do. The next thing I want to take a look at is this 2. This 2 here tells the location of the carbon with the functional group. So I know that when I write down my functional group, I'm going to write it on this carbon right here, carbon 2. Keep in mind, I could also write it on this carbon over here, which is technically, if you go from left to right, we would number it off as the 5th carbon from left to right. But remember, numbering technically is from outside inwards. So it's also the 2nd carbon over here and over here. So 2nd from left to right or 2nd from right to left. Remember, functional group, I said, is the unique part of an organic compound. That's worth writing down just because I'm going to use that term functional group a lot. And then also it's worth writing down that numbering goes from outside to inside. So it's not left to right or right to left. It's outside to inside. So you kind of have to number both at the same time. That's what I'm going to do right here. So carbon 2 is the 2nd one or this 2nd one, depending on which way you look at it. Okay, now I need to actually know what my functional group is, and that's where the suffix comes into play. The suffix is going to tell you the type of functional group. In this case, the suffix YNE, this is new information by the way, means triple bond. So anytime you see YNE, that means that on whichever carbon you need to use, you're going to put a triple bond. So in this case, I could put a triple bond between the 2nd and the 3rd carbon, or I could put it between this 2nd and 3rd carbon. I'm going to go from right to left this time, and I'm going to put my triple bond there so that the carbon has 3 bonds between carbon 2 and carbon 3. So we always say that 2 is where the functional group starts. So if it's a double bond, it's going to start on 2 and end on 3. Or if it was a 3, for example, it would start on 3 and then end on the other 3. So it would kind of be in the middle there. Another way of thinking about it, this is a little bit trickier, I think, is to think about, okay, I have 1 carbon bond, this is my first, and then this carbon bond would be my 2nd carbon bond, if that helps. Some of the other functional groups will actually just be on a physical carbon, like there'll be, instead of an H coming off here, there might be like an O or an OH or something like that. So that makes it a little bit easier. But for double bonds, it's wherever the bond, whatever carbon the bond starts on. So in this case, right here. Okay, so now we have all of our carbons. We have the carbon with the functional group, and we've got the proper functional group, a triple bond. All that's left is to just put in the hydrogens. So remember, every carbon needs 4 bonds. So just double check that once you're finished. Something people mess up all the time is they'll just put an extra 2 hydrogens on carbon 3 here and carbon 2 here. And then you'll end up having a carbon with, 6 bonds coming off of it. Not ideal. So be careful. Okay, so here's more general naming rules. Thing number 1, prefixes are the number of carbons. Now, I told you that 6 was for hex. It's a little bit complicated for the other ones. Specifically, take a look at 1, 2, 3, and 4. Instead of being like mono, di, tri, tetra, like it was for covalent, it's actually meth, eth, prop, bute. So you've probably heard of methane. Methane is CH4. You've probably heard of ethanol. Ethanol is also used in fuels a lot. That's a type of organic compound. You've probably heard of propane and butane. Those are also organic compounds. So instead of saying it's a tetraane, we say butane. It's just the specific rules. But the nice thing is that 5 through 10 are all similar. Pent, hex, hept, oct, non, and dec, you've probably heard before. For example, you've probably heard of octane before. That's what's in gasoline. So, okay, prefixes, remember, meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. You're going to want to write those down. You're going to want to know them. Oh, but actually they're on the back of the periodic table. So if you have a periodic table, add those. Or if you don't have a periodic table, I would add those. If not, just take a look, make sure that they're there. Okay, suffixes. There are three suffixes we're going to learn today. Single bonds is ane, double bonds is ene, so it's ain, een, and then triple bonds is yne, ein, is kind of how they end. So if you had a triple bond on a 5 carbon, it would be pentyne. If you had a double bond on a 30 carbon chain, it'd be propene, for example. But then, of course, depending on where you put that double bond or where you put that triple bond, you would have to write down which number it's on. So, for example, this problem down below, it's got 6 carbons, so that's hex. The triple bond looks like it's between the second carbon and the third carbon, because remember, you can count from outside in. So we would put 2 next to that, and it's 6, 2, and then it's got a triple bond, so it'd be YNE. So it would be 2 hex and then YNE, or 2-hexyne. Does that problem look familiar? Yeah, we just did it, right? So be sure that you can feel comfortable going from formula to name and name to formula. One of the ways to get comfortable with this is to actually use this thing that we call the organic naming flowchart. I designed this myself. It turns out that the steps that we just learned today, which is look at the prefix, find the suffix, and then write down the number, are steps that you're going to use for every single organic name we're going to come up with. So this should be posted on Schoology. I want you to download it and make sure that you have a copy. No, write down meth, eth, prot, bute, pent, hex, hept, oct, non, dec. That's kind of my first step. That's the first thing you want to look at. How many carbons does it have? That's your prefix. Then the second question you're going to have to ask is, does the hydrocarbon have multiple bonds or a functional group? And then based on what you get there, that's going to help you go further. Right now, we learned about double bonds, triple bonds, and if they're all single bonds. As we move further, we're going to learn about ethers, alcohols, ketones, and carboxylic acids. So this is going to help you know the prefix, the suffix, and then lastly, you're going to have to look at which carbon is the functional group on. And remember, you go outwards to inwards. So if it's on the left side and it's the first carbon, or if it's on the right side, it's also the first carbon. So then you put a 1 or a 2 or a 3 or a 4 or a 5. So we're going to keep using this organic flowchart as a way to kind of organize all the information in this chapter. And then hopefully by the end of the quarter, or by the end of this chapter, you should have this all filled in and you should know how it works. The easiest way to feel more comfortable about this stuff is to practice these structures. So we'll do some in class, but here's just kind of a couple examples of some structures that we'd ask you to name. These are just structures that exist. You don't have to do anything with those. Or you should also feel comfortable drawing structures given the name. Here are some more complicated ones involving double and triple bonds. Again, I've kind of numbered them off for you, so remember that you always go from the outside inwards. And then here are some other structures for you to, given the name, draw. And then here are some even more challenging ones for you. And some even more challenging ones to write the formula for as well. So for example, this first one, eth means that it's 2 carbons, so I would say C2. And then ene means that the formula, it's a double bond. So we would just have 4 hydrogens in this case. So it's C2H4, for example. Okay, it's a lot of information, but the good news is the next couple of days of notes are going to be really, really easy, really, really cakey, really, really straightforward. So I hope you enjoyed watching this video. If you didn't, feel free to, just do something with it. I don't know. Anyways, have a great day, guys. We'll see you next time.